Welcome to our demo on platform-agnostic interoperability. We will first briefly discuss general interoperability between platforms, highlight the challenges, and finally demonstrate our solution. Let's begin. Let us consider two platforms, A and B, who wish to exchange open data. Traditionally, this is done by implementing dedicated APIs at each end. However, consider now a third platform, C, with which platform B would like to communicate. This would require implementing another dedicated API pair. Extending this to N platforms who wish to interoperate with M platforms leads to an N-squared scaling problem. This is not ideal, as it requires new infrastructure for each pair. In premise, we consider instead a single API implementing a new protocol using JSON-LD to semantically annotate metadata and the RO-Crate specifications to package metadata. Both contain references to ontological concepts in online knowledge bases that interconnect ontologies via object, predicate, subject triples, as defined in the RDF specification. As a use case, let's consider a first underscore name field with the value John and the contextual meaning associated with an internationalized resource identifier, or IRI, pointing to the schema.org concept of a given name. Let's say we'd like to communicate John to someone who understands the same given name concept, but uses a different field internally. Using our field, value, and context, we can perform a JSON-LD expansion operation, assigning the value John directly to the given name IRI. Next, we perform a JSON-LD compaction operation using the target's context, which maps John onto the target field. We will now demonstrate this interoperability protocol using mock-up web apps. Here we have two apps implementing the new transfer protocol. On the left, we will mimic the OpenBiz Electronic Lab Notebook, or ELN, and on the right, the AIDA Workflow Manager. In the data viewer, each entry has an ID, an internal type, a title, and an IRI. The entry's metadata can also be viewed below, alongside its associated context, where many fields are semantically annotated with IRIs, both custom and of schema.org. In the Crate port, we can connect to OpenBiz, at which point, an API request for ontological types, or IRIs, is made. OpenBiz responds to our request by packaging its available types in an RO-Crate named ontologies.zip. The archive includes a description of the zipped folder and of the ontologies file marked as a response type. The API provides an endpoint to view the contents of the ontologies file. The content of the file populates the ontology dropdown at the AIDA Crate port. Note that some concepts are mutually understood, such as that of a molecular entity. We can then fetch molecular entities from OpenBiz. OpenBiz packages its objects in a new RO-Crate, here named objects.zip, with the objects file marked as the response type. We use the API to view the generated objects file. Here, each object, or entity, is merged with its associated metadata context as defined in OpenBiz. We choose to import the methane molecule. On import, the metadata of the molecule is expanded by OpenBiz using its context for molecular entities. AIDA compacts the expanded metadata using its own context for molecular entities, mapping the metadata values to AIDA's internal schema. Note that an additional metadata field is introduced to mark that this sample was imported from OpenBiz, or port 5001, with the OpenBiz ID for the sample. This will be used later by OpenBiz. We now proceed to submit a mock simulation on the imported methane molecule. This produces a new simulation entry, with the sample ID added in the simulation metadata as its parent. The simulation ID is also added to the sample's metadata as a child. We wish now to export the updated molecule to OpenBiz, which we can do from the Crate port. This prepares an RO-Crate, using the sample ID as the name, marking the included sample file as an export type. We use our API to view the exported sample, noting again that it is packaged along its metadata context. Viewing the sample metadata in OpenBiz, we see that the sample includes a reference to the simulation using its own internal key. This again highlights the use of JSON-LD's expansion compaction algorithm in facilitating platform-agnostic interoperability in open science. Thank you for watching.